Hi, I'm Mark Rosenzweig, Editor-in-Chief of Chemical Processing Magazine, and I'm concerned about the erosion of the U.S.'s stature in science and engineering. Every 2 years, the National Science Board of Arlington, Virginia, must submit a report to the President and Congress on the state of science, engineering, and technology in the U.S. The board released its latest report, Science and Engineering Indicators 2010, in mid-January. The hefty volume, which represents efforts of well more than 100 contributors and reviewers, contains a wealth of quantitative data compiled from public and private sources around the world. The report doesn't include any policy recommendations. Instead, it aims to put trends and developments in the U.S. and elsewhere into perspective to aid U.S. government policymakers. SEI 2010 offers interesting but sobering reading for technical professionals in the U.S. In most broad aspects of S&T, or science and technology, activities, the United States continues to maintain a position of leadership, but has experienced a gradual erosion of its position in many specific areas, says the report. Two contributing developments are the rapid increase in a broad range of Asian S&T capabilities outside of Japan and the fruition of European Union efforts to boost its relative competitiveness in R&D, innovation, and high technology. Asia's rapid ascent as a major world S&T center beyond Japan is driven by developments in China and several other Asian economies, the so-called Asia 9, India, Indonesia, Malaysia, the Philippines, Singapore, South Korea, Thailand, Taiwan, and Vietnam. All are seeking to boost access to and the quality of higher education and to develop world-class research and S&T infrastructures. Japan, long a preeminent world S&T nation, is holding its own in research and some high-value S&T activities, but losing ground to the Asia 9 in overall high-technology manufacturing and trade, notes the report. The EU largely holds its own in the face of the worldwide S&T shifts, it adds. While more money was spent on R&D in the U.S. than in the EU or Asia, much higher annual growth rates in R&D spending in some Asian countries are closing the gap. U.S.-based multinational firms are conducting more of their overseas R&D in emerging Asian economies rather than Europe, Canada, and Japan. In terms of R&D spending as a share of national economic output, South Korea now leads all countries. The geographic distribution of authors of articles in peer-reviewed research journals provides another indication of a shift. In 2008, China ranked second, accounting for about 8% of world article output, up from 1% in 1988. The U.S. still had a sizable lead. The nature, not just the number of articles, also is revealing. In 2007, more than half of U.S. articles related to biomedical and life sciences work. In contrast, Asian researchers focus more on the physical sciences and engineering. China, in particular, placed an emphasis on chemistry R&D, with such articles accounting for nearly 25% of its total in 2008. China's output of engineering articles increased by nearly 16% annually compared with 2% a year growth rates in the U.S. and Japan, and 4.4% a year in the EU. In 2008, China produced almost 50% of all engineering articles. However, this activity hasn't translated into increased Chinese filings for U.S. patents yet. China's share of U.S. patents granted remained at about 1% from 1995 to 2008. During the same period, the Asia 9 share rose to 10% from 3%, mostly due to South Korea and Taiwan. Of course, ongoing vitality in publications and patents, and technical professions as a whole, depends on an adequate future supply of scientists and engineers. Governments in many Western countries and in Japan are concerned about lagging student interest in studying natural sciences or engineering, fields they believe convey technical skills and knowledge that are essential for knowledge-intensive economies. In the developing world, the number of first university NS&E degrees, broadly comparable to a U.S. baccalaureate, is rising, led by large increases in China, from about 239,000 in 1998 to 807,000 in 2006. This is just a tiny smattering of details in the volume, which contains 7 core chapters. Elementary and secondary education, higher education in science and engineering, science and engineering labor force, research and development, national trends and international linkages, academic research and development, industry technology and the global marketplace, and science and technology, public attitudes and understanding. The entire report is available as a PDF at www.nsf.gov.